Yeah, but I mean, I warned them in advance. I'm like, if you do this, this is what's going to happen. And then somebody did it, and I was like, it happened. So, it's no surprise. All right, so here we have the vertices of the triangle. We need to find the area. And so we learned yesterday that the area of the parallelogram is the same as the magnitude of the cross product between two consecutive sides. So if we find the cross product between two consecutive sides and the magnitude of that, we'll be good to go. The other way to handle it would be to actually find the angle separating the two sides. In this case, you might go in either direction because at first glance, anyway, it seems like the numbers might be kind of nice. All right, so I'm going to find vector p to r, the displacement vector p to r, and bless you, the displacement vector p to q. That's how we got started with it yesterday. So p to r, so negative 1, 0, 1. P to q, negative 1, 1, 0. All right. Now, again, there's two ways to do it. One way, again, would be to find the cross product, which wouldn't actually be overly challenging in this case either. So you could do it that way, or you could use the magnitude of PR cross PQ is equal to the magnitude of PR times the magnitude of PQ times the sine of the angle between them. I got trig on the mind after the trig identity story, so I kind of feel, I almost fell. I kind of feel into the idea of doing it with the trig component. So I need the angle. If I'm going to use the angle, I'm going to use my angle formula, or if I'm going to determine the angle, I'm going to use the angle formula. So cosine of theta is equal to, in general, u dot b over the two magnitudes multiplied. All right, so in this case, it's the magnitudes of these two jammies, so I'll just crank that out real quick because it's very easy. That's the other reason why I'm choosing to do it this way. So it's the sum of the squares rooted. It's going to be root 2 in both cases. 1 squared plus 0 squared plus 1 squared. 1 plus 1 is 2. The dot product looks like just a 1. So to get the angle, we're dealing with cosine theta is equal to, we've got the dot product is 1. The two magnitudes are root 2. So cosine theta is equal to 1/2. I could just write this as an inverse. You know, theta is equal to the inverse cosine of 1/2 and just plug in the inverse cosine of 1/2 for the theta in the sine. That's it, you know, worst case scenario if you have no idea what the angle is in the unit circle, that gives you a cosine ratio of 1/2, but we all know that. That's what? 60 degrees. 60 degrees pi over 3, it doesn't matter as long as you're consistent. So don't put 60 degrees over there and then, like you have your calculator in degree mode and then use pi over 3. You know, that wouldn't shake out too well. All right, so my two magnitudes. Oh, sorry. Found the magnitudes, didn't actually write magnitude. So rad 2 times rad 2 times the sine of 60 degrees. So 2 times root 3 over 2, which is root 3. Now, again, that's the area of the parallelogram. Right? That's the area of the parallelogram that we create. And it's three-dimensional parallelogram. It's not a parallelepiped. It's a parallelogram in a plane that's not the xy plane. All right? I want the area of the triangle, which is going to be that measure cut in half. So root 3 over 2. Or, like I said, you could have done it with the cross product. With your two vectors. So negative I. Let me look at this guy. Diagonal down, diagonal up on those two. Looking at these guys. Negative for the formula, or the power of -1 relationship. Diagonal down is 0, diagonal up, so minus -1, so plus 1, so minus k because of the minus built in. And then k, diagonal down -1, diagonal up 0, so negative, oh, sorry, j. That was a weird one. K negative, so negative k. All right, so my cross, PR cross PQ, we could write it in vector form, or you could write it in, oh, we already have it in IJK form, but just to see what the coefficients are, because then the magnitude. Pretty easy. And again, that's the area of the parallelogram. If I want the area of the triangle, just chop it in half.